Welcome to this video. Now we're going to talk about Raspberry Pi as an edge device in our project. Now this project is similar to the last one, but here we are using Raspberry Pi. Now I've written here edge device. Now what is an edge device? Now Raspberry Pi professionally it's not an edge device, but we can use it as an edge device because it's not so robust device that we have in the industries. But to initialize your projects for IIoT, you can use it as an edge device. Because in general, edge device has a functionality to capture the information from different sources. And we will see in this example how we will use Raspberry Pi to take information from PLCs. Or further on in the project, we will see how we can use Raspberry Pi to send the information to the cloud and then read the information back. So it is taking the information from the local environment and sending to the cloud and bringing it back. So the Raspberry Pi which I'm using here is this one. So that's my Raspberry Pi 4, and this is going to be reading information from the PLC. Okay, so what are the steps involved? First is you need to have this device, and I would definitely recommend you because it's not so expensive, and for students to buy this device, it's a must because your Node-RED is working in this Raspberry Pi just like your Windows computer. So if I show you my screen, I'm using VNC Viewer to view my Raspberry Pi device. So this is my Raspberry Pi right now. This is the operating system inside. It's called Raspbian operating system. So you need to install this operating system. And most of the time when you buy a Raspberry Pi, it comes with this operating system inside it. So when you just have to turn it on and you will see a window like that. Of course, you have to log in with your ID and password, which is by default Pi as a username and Raspberry as a password. And then you have to go to your terminal and just type here Node-RED. My Node-RED service is already started, so anyways, it will start just like you did in your computer. Here, the only difference is you have a Linux environment. So when your Node-RED is running in your Raspberry Pi, it says it's already in use because it's already running. So you will open your localhost 1800 as a port and press enter, and you will see a Node-RED screen like that. Okay. So in my Raspberry Pi, I already have some nodes defined. So we are not going to use that because I'm controlling my house lamps via some Shelly devices via Raspberry Pi and using some Telegram integration as well. But anyways, in this project, we are just going to use OPC UA to read the information from the PLC, just like we were doing in the last project. So one thing I have to also mention you here that now this is the Node-RED in my Raspberry Pi. If I want to access this Raspberry Pi in my computer, okay, now let me show you my network structure at the moment. So what do we have here? We are having a PLC device. Okay, where is my pen? Okay. So we are having a PLC, S7 1200 PLC. Okay. Now this PLC is connected to my network, and let's say this is my Ethernet switch. I should actually take a little bit thicker, maybe this one. So I have an Ethernet switch, and this is connected to my PLC. So I have an Ethernet connection like this. And then I also have my PC here. And this is also connected to my Ethernet switch. And then I have my Raspberry Pi. Okay, by the way, this Ethernet switch is further connected to my router. The function of this router is very simple. This is actually converting this wired signal into wireless. So my Raspberry Pi is connected to this Wi-Fi device, which means they all are connected to each other. The only difference is this is connected by wired and Raspberry Pi is connected via wireless. That's the only difference, but they are all connected together. So I was using VNC Viewer in my PC to view what is inside my Raspberry Pi. So Raspberry Pi also has a VNC Viewer, and this is the way to visualize other devices in this computer. And this is also happening via this Wi-Fi signal. Okay, so if I'm showing you this window here, this is coming from Raspberry Pi via VNC Viewer. Okay, so this VNC Viewer is a software where I just have to enter the IP address of my Raspberry Pi, put the login information, and I can view my Raspberry Pi computer. Okay, but this is a bit slow because this is working over the Wi-Fi signal. It's not a real time. So if I use my nodes, it's kind of a bit sluggish performance. Okay, so what I'm going to do is I'm going to directly access my Node-RED, which is in the Raspberry Pi, in the browser. So what I'm going to do is this PC, I'm going to use a browser. Okay, wait. So this browser has the capability to read the Node-RED server, which is in the Raspberry Pi. So it has its Node-RED, which is running inside the Raspberry Pi. I'm going to read this Node-RED server into my PC. Okay, how do I do that? Because Raspberry Pi has its own IP address. So let's see what is that. So I just need to know the IP address of my Raspberry Pi. I can go to my Wi-Fi signal and I can see IP addresses 192.168.0.149. Okay, so I just need to know its IP address, which is 192.168.0.149, and for Node-RED the port is 1880. So if I enter this port into my PC, this port, I can access the Node-RED, which is inside my Raspberry Pi in the PC. Because I'm recording this video in my PC, it's more convenient for me to record what I'm going to do in Raspberry Pi for this project. So this is the startup information which I wanted to tell you. So now you see this is the local host. This is the nodes running in my computer, which we did in the last project. Now I'm going to open for the Raspberry Pi 192.168. You can see here .149.880, and I press enter. Now I see this Node-RED, which is in my Raspberry Pi. You can see it's the same Node-RED. That's the MQTT window, and it's the same here. All right, so I'm going to close this VNC Viewer. I don't need it anymore. Now this is the Raspberry Pi this is a Node-RED for my Raspberry Pi. All right, this is what I wanted to show you before I start my project. So if you see the project layout again, we have now Node-RED running in the Raspberry Pi already. What I need to do is I need to use OPCUA nodes to read from the Siemens PLC. So I can also copy these nodes. Let me just try. So I press copy. I'm not sure. No, I can't do that. I can't copy. Okay. So I need to do that by myself again. So this is my MQTT flow I took in Raspberry Pi. So make sure you have installed this OPCUA client in your Raspberry Pi. And maybe what I can do is I can do one thing. I can go to export, current flow, formatted, copy, and go to my Raspberry Pi and import. Paste here, import. Yeah, this works. Perfect. So let me see that. This was basic project 2. Let me delete that. Let me change this to basic project 3. Okay. So here in the client, this is defined. Looks great to me. Done and deploy. That's active. Okay, MQTT, I will check that. So I have my OPCUA, and let's see if I can read it. Yes, I can read it. Value 3 is coming in the Raspberry Pi. Value 2 is coming, and value 1 is coming. And about this MQTT now, very interesting. So this part is done. I will connect to the factory IO as well in a minute, but let me just verify the MQTT nodes now. So coming back here to our nodes. So in the last project, I have defined MQTT in my PC. Okay. This was already in my PC via Node-RED. Now we need to define MQTT here in our Raspberry Pi. So we do the same projects because I just copied the code. That's why it's looking for something. So let me see if I have a broker. I have a broker. No, this is Mosca. Let me install the broker. Manage palettes. Install. Let's installing the broker. I already have a broker in my network, but that broker is for my PC. Okay, now we're gonna do the broker in Raspberry Pi because we're gonna eliminate the PC. We're just gonna use Raspberry Pi in the project. So I need to install the broker as well. So we wait a couple of seconds until we find the broker. In the meanwhile, what I can do is I can open my factory IO environment, because we're going to read the level and we're going to control the outputs. So if you don't have factory IO, you can still practice just by using a PLC. If you have a factory IO, that's interesting because this makes the exercise a bit interesting. Okay, so we have this factory IO here, and I go to my drivers. I'm going to use S7 1500, and let me just use, okay, I don't remember which was, okay, I can use this one. I go to configuration. This is the IP address of my PLC. This is correct. The outputs, so let me see in my PLC which outputs I already have, because I have something in my tags. So for level, I'm using ID 100. So I'm going to use here, word is 100. So let me go back and driver. Okay, so you can see that it's 0 and it's 0. I have to change it. I can do that in case if my level is analog. Okay, now drivers. So I don't need this, don't need this, don't need this. This is still Boolean. Wait a second. Boolean. Okay, here it is for the word. I need input 1 and output 2. I don't need any Boolean, so I make it 0. Go back. Now you have ID 100. I connect level meter to that. QD 100. Let me see, what is that? Filling is 100, draining is 104. So filling is 100. Oh, sorry, this one. Draining is, or discharge is 104. This looks nice. I go back to my configuration to check. Yeah, it's okay. And I connect. So now my PLC is connected to factory IO. So this part is done. Let's see how our Raspberry Pi is doing. Okay, broker is installed. I have my broker here. Okay, so still looking for a connection. I will give him the connection very soon. So port is 1883. No security. I can give a security again. Node-RED is username. Password is :compile. Done. And now let's assign the broker. I can do localhost, but here I prefer to use the IP address of my Raspberry Pi 192.168.0.149. And this is okay. Let's give it a name. Broker RP is the Raspberry Pi update, and done. So let's deploy. Disconnected. Let me check. What is the problem? 192.168. Okay, I didn't add the IZN password. Node-RED. Code and compile. Update. Done. Deploy. This is connected. Let's change that as well to broker RP. Done. Broker RP. Done. Deploy. So now my MQTT is working. So in the project, if we go back, this part is done, OPC UA is done, and this is done. Now we have to just connect this factory IO to the tags and see if we can read the tags via MQTT. Very simple. All right, so this was reading value 3, value 2, and value 1. But now we have to read something else. We have to read QD 100, 104, and ID 100. So what I'm going to do is I'm going to change, or I'm going to add some tags. So what we can do is I can add here level, which is my real, filling, draining. So I add 3 more tags. Okay. So let me just, okay, now these tags needs the information from these real values. So if I go here online, so these values are at the moment 0. Okay, so these values should come in this database value. For example, let me go online. Okay, I have to download it first. This is just a basic lesson which you already did in your Siemens course. If you have joined my course, I have told you this 100 times, I'm sure. So we just need to move this value here. We will write a function. Okay. Now let's go online. Okay, so now these values are 0. So if I change something in my factory IO, let me just force the values, go to play. So I have my filling valve here and I push some values. So now level has some values. This is just to explain you. So level is 0.9 somewhere. And I can see this value here, but I can't see here in the level. So we need to move the value from our PLC tags to this tags and then bring these tags to the OPC UA. So first we'll write a function. So I'm going to add a new block. Function block. I will write read values. Let it be SCL. So we have to read the values. So this function is here. I will take it out. So we need to read this and put it into level here. So level will come first. Just drag and drop. And this symbol here and bring it here. That's it. Press like this. This is just for reading the value. I will put a comment. Reading level and the PLC database. Perfect. Just close it. Now we need another function for writing the values. SCL. You can also do that in the same function, but I prefer to make different one. Write values. Now what happened in write values? You have to, let me open this one. Here's my function. In the write values, we have to write what is in the database because this is the values which will come from MQTT. So these values should go to the tags. So this will come here first, filling. Filling should get the value from the database. And draining also. And I will put a comment. Writing the values. Perfect. Let's download that in our PLC. Download only changes. Load. All right. So this, okay, one thing I forgot. You have to call this function as well in your main project, in the main block. So reading the value, otherwise it will not work, and writing the value. I forgot that. Download only changes. Because we have made the function, but we never called that. So now loading it. Now we can see the values coming here. And if you want to see if the value changes, I can show you now. So I force the fill valve. And you can see that the value is updated. Now, great. So in this step, what we have done, we have read the information from factory IO, send it to the PLC. Now we have to do the OPC UA tags and bring it to Raspberry Pi and then send it to the clients. This we will do in the next video. This video is getting long. So in this video, we have seen how to use nodes in Raspberry Pi for OPC UA, and how to link factory IO with PLC, and how to link PLC to Raspberry Pi, and how to install broker in the Raspberry Pi for MQTT clients. So we have completely replaced the PC now. So in the next video, we'll see how to read these tags in the Raspberry Pi via OPC UA, and then define these tags to a topic and read via MQTT client. Okay, see you in the next video. Stay tuned. Bye.